Hey, what's up, y'all? We're just wrapping up Capital Audio Fest. One of the highlights of the show was when we got to see Andrew John's new speaker, the SourcePoint 10.
Welcome to MoFi and my first speakers for MoFi. It's been nearly 2 years since I joined MoFi and about 18 months since I solidified the concept of what I wanted to do for this speaker, because they basically gave me open book. You know, we've hired you, we know what you do, we trust you, come up with something. Great. With all the ideas I have in my head, what am I going to do? And there were just two areas that they sort of wanted to guide me on. They said, we love good, impactful bass. Okay, doesn't everybody? And the other was that what is popular right now is kind of throwback to mid-century modern. You see it in interior design, and we've seen it in reissues of some classic speakers. You know, you've got the JBL L100, the KLH, the Wharfedale Lintons. So big boxes are in, at least for a while, and for some customers. And that's sort of great news, because the trend for narrower and narrower speakers means there's no room for much of a bass driver on the front, and I'm not a fan of putting them on the side. It's just problems always in coupling into the room. So now I've got the chance of doing a big bass driver. And I've done big bass drivers, at least 10-inch before, when I was with TAD. So that's something that was going to be interesting to pursue. The other factor is I'm known for doing concentric drivers. So given the choice, I'll always do concentric drivers. And up till now, given the choice, I always put them part as a three-way system, because I want to minimize the cone motion so that I don't get modulation effects. The easiest way to minimize cone motion is to cut all the bass out of it, make a three-way, and use the concentric drive as a mid-range. If you cross over around 200 Hertz, there's just no motion of the cone that you can see even at high levels. But was that going to fit in with any idea of price point that we wanted to try and meet? Because now I've got a big bass driver, a big cabinet, and a three-way, and the cost just keeps escalating, and the complexity of the crossover is a lot to deal with when you're doing a three-way. So I'm thinking, well, I've got this 10-inch, and if I want to minimize cone motion, well, the bigger the cone, the less it has to move in order to create the bass. So could I do a 10-inch concentric and simplify things to a two-way? What would that sound like? So once I got this idea in my head, that's what I tried to commit to. Yeah, I've got this great concept. This is what the speaker's going to be. Now what's the reality? How do we actually engineer that? And the problem is, once I started to examine what I have to do to be able to build this driver, I realized that I can't use off-the-shelf parts. I can't even find cones that are of the right combination of shapes and what is called diameters and outer diameter. So I'm going to have to tool a cone, and tool the surround, and tool the tweeter, and tool up all the magnet system. So I'm going to commit upfront a lot of money to tooling an idea that I've never actually done before. You know, it ought to work, and there's precedence of, you know, large coaxers in the pro audio field, or with tannoy as a good example. I don't want to use a compression driver, so I want to be crossing over higher than they would be. So now I need a 10-inch cone that works all the way up to, you know, roll off at 3K, no cone resonances up to 3K. That's a tall order. What I do know is a lot of the pro drivers, they use them in systems where the bass driver is a bass mid and operating up to quite high frequency. So it's possible. Now I have to see whether I can make it a reality in the way I want to create the speaker. And that's what the next 6 months was for, to start playing with that idea and coming up with cone profiles that I might need and getting them tooled. And out of all the materials I started to look at, when you're talking about a 10-inch base mid-driver, the best materials still seem to be paper. And so we're talking about mid-century modern and throwback to the 70s. This is a real throwback back to paper, but worked for tannoy. And then I found a nice dome I can use for the tweeter, and it's a silk dome. So now it's a real throwback. I think, that's what I was doing at KEF when I first started, like 30 odd years ago. So where have we come since then? But there was this period of just working at designing and building all these things and having no idea how well it was going to work or how different it might sound until I'd got all the parts tooled and together, got the drivers built, got them measured, got the cabinet, put it all together, design a crossover, and for the first time in 6 months, get to listen to my first cut. And it was a make or break moment. And I listened and I go, ooh, this is interesting. It's maybe not the same as what I have been doing, but that doesn't mean it's not better. And so I thought, yeah, this is the path I want. And I did some tweaking around that, remeasured it, did some listening, and created this. So one of the issues you face when doing a driver that's working all the way up to, I want to cross as low as I can. So I got to engineer the tweeter to go down low enough. And I got it crossing over about 1.6K. Managed to push the first cone resonance up to about 3.5K. So I got a nice region where notionally, if I cross over well enough, I don't excite that cone resonance. But the problem, that's thinking in a linear world. But drivers are non-linear. The motor structure introduces distortion, both harmonic and intermodulation distortion. And the problem with that is that they're created from signals that got through the crossover and are generated after the crossover. So imagine a crossover at 2K, and I put in a 1K tone, 1K comes out. 3K, nothing comes through, and that's where the cone resonance is. But if I've got distortion, the third harmonic of 1K is 3K. That's coupled directly to that cone and hits the resonance, and so magnifies the distortion level. So it's important when you're operating close to the vicinity of those cone resonances that you have a very linear magnet structure. And the other problem with the magnet structure is I've got to fit it all within the voice coil, both the bass driver, motor structure, and the tweeter. And often you're starved for strength from the magnets to create all the fluxes you need. So what I was able to do is create a new compound, we call it twin drive, because the tweeter magnet and the bass magnet couple together and drive flux through each other's gaps to increase the field strength in them. And also because I'm an identical twin, so I thought that was really cool, twin drive. So I had to come up with all this structure and squeeze it in there, and now I've got my drive unit. And so paper and silk, where we progressed. Now, one of the things that's important with any driver, but also with a concentric driver, is as the sound spreads up the cone and gets to the baffle, as it gets to the edges of the baffle, it re-radiates and causes baffle diffraction effects. So you always want to try and minimize those. And one of the key things is if the baffle goes backwards first away from the driver before it hits an edge, then it minimizes the disruption of that re-radiation. Now I did that with all the TAD speakers, the smooth, continuous, backwards curving surface. You look at KEF LS50, they do the same thing. Before it hits that square baffle edge, it's curved backwards. The other way to do it is, let's say, a piecewise approximation to a constant curve. You cut facets. So all different distances all around the driver and different angles of facets moving backwards. And so that helps disrupt that diffraction. So that worked quite well. I got foam core board and kind of cut it up into that shape to test the idea. The only difference there is I've added, because of the mid-century modern vibe, I've added the picture frame around the edge of the cabinet. Now, normally on a flat baffle, putting a picture frame coming forward would really mess up the diffraction, but because it's now behind the plane of the baffle, it doesn't have too much effect. There's a modest effect, but not disastrous. To sculpt that baffle, it's all made of MDF, needs a 2-inch thick baffle. So it's a very strong baffle structure. And the rest of the cabinet is 1-inch thick walls for the top, sides, back, and then 2 vertical braces in addition to help strengthen the cabinet. So it's a very strong, heavy structure, 46 pounds. It's about the limit at my age of wanting to lift and move around places to measure. And then a vented system. And the other nice feature is it's a high sensitivity, 91 dB of true measured sensitivity, and at 8 ohms, and not one of these fake kind of 8 ohm compatible ratings. It's a minimum of 6.4 ohms around 150 hertz. And everywhere else it's above 8 ohms, close to 10 ohms and beyond. So it's very easy to drive and makes it less sensitive for different tube amplifiers trying to work with it. And then goes down to minus 6 dB at 42 hertz if you measure anechoically, and in room, who knows, depends on the room. But I get strong output in the mid-30s in my listening room. But I don't put that in the spec because who knows what room and room positioning you're using. And then a grill, and we wanted, so this is quite a striking look. As I say, there's other companies that use faceting, but we're kind of incorporating new and old together. But we have a molded grill, which is quite open, so it has minimal influence on the sound. But when you put it on, it keeps the same kind of view of the kind of faceted design, but just softens it down so that if you think it's a bit too severe, you can keep the grill on, soften it off, and not light it up to further emphasize the facets. So that's the speaker, and we are driving it with Hi-Fi Rose equipment, the 150 server and the 180 amplifier, and streaming in this instance from Qobuz. So let me play different types of music to illustrate aspects of the performance. And I'm going to start, since it's kind of vintage, start with a recording that's as old as I am. This is Harry Belafonte live at Carnegie Hall, and it's beautifully recorded voice, and you can hear the space that it's in, and it makes you think, where have we come in 60 years for recording techniques? But let's hope this works first time. Stay with some earlier recordings, keep our fingers crossed, and then this is Count Basie Orchestra, Bluesville from 88 Basie Street. Always the imaging, again from concentric drivers, it just fills the space in front of you. So since we've got this big bass driver, and one of the prime directives from MoFi was big, impactful bass, I'll play 2 tracks to illustrate that aspect of performance. God, I feel like I'm a Tesla operating this thing, but okay. This is Marion Hall. I always used to play with the previous company. When I developed the B5, I was showing just what a compact loudspeaker with a 5-inch bass driver could do from a point of bass. But obviously limits to what a 5-inch driver can do. This isn't a 5-inch driver. So let's play that same track I used to play at the other shows, Dead Mouse and Sia. So there you have it, 3,700 a pair, $36.99. I won't charge you the extra $1. Show special, charge you an extra $1. We're making custom stands. They'll be available about a month after release of the speaker, which will start shipping beginning of December. And the stands, something like an 8mm thick steel plate for the bottom, 3mm thick for the top, 10-inch square top, so you've got plenty of support for the speaker. And then the 4 columns are fillable. And once filled, just very solid. I use cat litter, by the way. I go across to the store and fill it with cat litter, and it works very well. You're not having to run off to find sand or lead. Fresh Step Crystal, that's the one to use. Anyway, thank you for coming. I hope you enjoyed it, and have a good day.